Hello everyone, my name is Manas Pathak and I welcome you all to the last part of our video on topic statistical characterization. In the previous part, we understood how to calculate median for a continuous distribution. Today we are going to look at some more statistical measures and visualization tools. Like always, we are going to understand these concepts by solving certain questions of first internal test, part A, statistical characterization. I am a student of IIPS DAVV, so let's start. So this was the question which we solved in last part, the link for which you can find in the description of this video. So now the question for today we have is, in the Department of Lifelong Learning, a feedback survey collected both student age and their self-assessment of learning productivity percentage for 18 students. Now we are given three parts in this question. First, in the first part we have to calculate the mean, median and standard deviation for age and percentage productivity. Part B, draw the box plots for both. Part C, draw a scatter plot and a QQ plot, which is quartile plot, to study the relationship. Here is our data. The data in blue color represents the age and the one in the black color represents the productivity percentage. So now let's solve this question. First, let's find mean and median. So as we have already seen the formulas for mean and median, for mean the formula is sum of all frequencies divided by total number of frequencies, which is 18 in our case. So sum of all frequencies for ages is 836, dividing that by 18 gives us 46.44. Similarly, sum of all productivity percentage values is 518.1, dividing that by 18 we get 28.78. Hence these are the respective mean for age and productivity. Since we have 18 total number of frequencies in both age and productivity data, we'll use the median formula for even frequencies, which is the average of n by 2 and n by 2 plus 1 at terms. For age, these terms are 50 and 52. Taking average of these two values, we get 51, which is our median age. And for productivity, these values are 31.2 and 34.6, average of which comes around 32.9. Hence 32.9 is our median for productivity. Now let's move on and find the standard deviation. Here is the formula for standard deviation. Let's understand its elements one by one. Here S represents the standard deviation, Xi is the ith observation, which means since we have 18 total number of observations in our data, the value of I ranges from 1 to 18, and for each value of Y, Xi contains a value from the data. X dash represents the mean, n is the total number of observations. Now let's look at this formula. The numerator is summation of squares of differences between the data points from the data mean. So basically, the difference between data point from its the mean position is called deviation, and when we square these values and take sum of all squared values, we get our numerator. In denominator we have n minus 1, and if we don't calculate the square root of this value, then we get variance, but by taking square root of this value, we get the standard deviation. Hence this is our formula for standard deviation. So using this formula and using these terminologies, we can easily calculate standard deviation. You can calculate it by yourself and verify that the standard deviation for age is 12.84, while the standard deviation for productivity is 8.99. Next, we have plotted box plots for both the data sets. The blue one represents the box plot for age, while the orange one represents the box plot for productivity percentage. As I have already told you, the whiskers represent the minimum and maximum value, while the two top and bottom edges represent the first and third quartile, and the line in middle of the box represents the median. The two dots at the end represent the outlier values. So hence this is our box plot. Then the scatter plot, it is a bivariate plot, hence it plots both age and age with its corresponding value for productivity. So this is our scatter plot. Scatter plot is generally used to identify relationships and dependencies between two variables or features. Then this is my quantile plot, which plots respective quantiles for both age and productivity on x and y axis. Since we can see that the quantile plot is not a straight line, we can conclude that the both distributions are not similar to each other. Hence, we have now successfully solved our question number 4, and this was all for today's video. I hope you learned something today. I would like to express my heartfelt gratitude to Dr. Shaligram Prajapat for their guidance. If you like this video, please like the video and consider subscribing to my channel. I'll come up with more such exciting topics. Thank you.